This is the third video for the 6667 practice test. So here, excuse me, we're solving some exponential inequalities. So I'm going to treat this just like an equation. And to solve for x, I need to rewrite this as a log. So log base 3 of 100 equals x. And so if I want to solve for x here, x is going to be log 100 divided by log 3. So when I plug this in, I get x is about 4.192. So I need to rewrite this back as an exponential. So 3 to that power, 3 to the fourth is definitely less than 100. 3 to the fourth is 81. So I want this to be a less than symbol. So I'm going to say that x is less than 4.192. If x were greater, let's say 5, 3 to the fifth is larger than 100. That's 81 times 3, which is 243. So that wouldn't work. So this is consistent. And if I pick something really small, like a 0, well, that's fine. 3 to the 0 is 1. If I pick something smaller than 0, like a -1, 3 to the -1 is a third, and a third is still less than 100. So zeros work here, negatives work here, so I don't need to build a compound inequality. Over here, so again, I want to get this, sorry, we're a little out of focus. We want to get the x alone, so dividing both sides by 7, e to the x minus 3 is greater than or equal to 15/7, which means log natural of 15/7 is somehow compares to, I'm going to just replace it with an equals for now, x minus 3, add 3, add 3. So x is log natural of 15/7 plus 3. So kind of gross, but I can just use my calculator to plug that in. So when I evaluate that, I get x is about 3.762. And again, I'm going to keep my symbol the same as I had up here. So x on the left greater than equal to, x on the left greater than equal to. And I can check this by picking something slightly bigger, like a 4. So e to the 4 minus 3 is e to the first power, which is 2 and some change. 2 and some change times 7 is a little bit bigger than 14, which would be this. And remember, e is, if I take e, and just to give you a better sense of what that looks like, if I take e and I raise it to the power of 1, that's 2.718, and then I multiply that by 7, and I get about 19. So definitely 19 is bigger than or equal to 15, so that works out as well. And again, I have no restrictions here because everything's going to be bigger, so I don't even have to worry about zeros or negatives. Down here, number 10, which is right here, 3 times log natural of x. Let's see, I just want to make sure this is written properly. 3 times log natural of x minus 1. So this is not x minus 1, it's x minus 1. So it's log natural x minus 1. So to solve here, I'm going to add 1 to both sides. And I have 3 log natural x is less than 24. I'm going to divide both sides by 3, and I have log natural x